Okay, so logarithms and exponents are today. This is order, so hopefully nobody comes around and creates issues. You should have paper out taking notes, unless you're just going to gather it by osmosis, which is fine too, but I highly doubt it. Switch off. So I'm going to start with the basics of logarithms and switching between the two different forms. We don't talk a whole lot about exponents in Math 3, other than the fact their connection to logarithms. So, and I don't know how far we'll get. We may get through it all in an hour, or we may get through it all in 2 minutes. Who knows? Crazy things have happened. So, I think everybody here knows what an exponent is, or you're probably in trouble. So, we have some number, we'll call it x to the power of y equals some number, right? Where y is our exponent and x is considered to be our base. Okay, so that's the exponential form. To switch it into logarithmic form, which remember logarithmic form is just a fancy way of writing it. It's basically the inverse of it. It would be log base. I told you it goes in the basement, so it's down here. Okay, so base in basement. The exponent is in exile, so it's out here. And don't forget, exile means by itself. And then the number just fills in the other thing. Okay? When I say log base, I'm talking about like log of a certain number. So if I don't have an actual number there, so if I just have log of 100, can you remember what base I assume? 10. Very good. So it's log base 10 of 100. We just didn't actually write it. Okay? Which is basically saying 10 to what power equals 100, which we know is 2. Okay? Anything else, if it is 7 or whatever, it'll actually say, log 7 of some number, instead of just applying. Okay, I saw most of you struggle with is actually switching between the forms. I think you made it just harder than it is. So always remember it's log base of some number equals your exponent. So writing it like that helps. I don't know. I've tried a couple different ways. I don't think necessarily this is per se going to be tested on, but you have to understand this concept to be able to do some other stuff with it. Like if I told you to solve for log base 5 of 25, let's do 125. Log base 5 of 125. How could I find that out? Any ideas? What's my base? 5. What's my exponent? Do I know? We're equaling some crazy number, right? That we don't know. So 5 to what power? We'll say x. 5 to power x equals what? Equals 125. Well, you could sit there and play with it for a minute and realize that 5 to the power of 3 is 125. So you just solved for this by switching in exponential form. So knowing your exponential form can help you with that. It can even help you solve other more complicated equations. Give me a second, I'll find a good example for you. Okay. So if I said solve, and I gave you log of 4x equals 2. Okay, that's a slightly more complicated problem than what we had originally, but by switching it in exponential form, it's really not that hard. What is the base? If there's nothing there, it is 10 raised to the power of 2, very good, equals 4x. Okay, base to the power equals number. Okay, that's why it's the inverse of it. Normally we're taking exponents and solving for whatever it actually equals. Here we're saying, hey, what to the power of? What's that actual exponent? So logarithms find that exponent portion. So 10 to the power 2 equals 4x. Well, 10 to the power 2 is 100 equals 4x. So divide by 4 and say, hey, x is 25. Okay. You could technically plug in numbers too. I mean, that's not an awful idea if that's all you can do, but it's not the technical way you should be able to solve it. Is there any questions about that? Anybody not okay with switching it into different forms? It's okay if you're not, I just need to know. Okay. If you want more examples later on, just let me know and I'll give it to you. Don't mind at all. Okay, so if you know how to switch forms, also know one quick trick. If you didn't know log base 5 of 125, you could have typed it into your calculator. I know that we've kind of seen on calculator before. Oh, wrong thing. We had, if you type in log, it doesn't give you the option for base. You technically could go to, I think, math. Somewhere it says log base. I don't know. Oh, it's in that special thing. If you have an updated calculator, okay, so not all of them, hit the alpha and then try the, I think, alpha 2. It gives you log base, option 5. I'm not guaranteeing you on test day you're getting an updated calculator. I'm literally handing you a calculator, and I can't change what you have. So I could say log base 5 of 125 in that case, but I still can't guarantee that. So I would not bank on that being an option. What you need to know is change a base. Change a base means you neutralize it to both of them being base 10, and you say log, normal log of 125, and then we divide it by log of 5. and it gives you the same thing. So it's log of the big number divided by log of that base number. Okay? And you may want to write that down. So change of base is, if we have log of xy, it's log of y over log of x. Any questions about that? Everybody have this down? Okay, so the next one, this is really where the struggles began when we went over this, if I remember correctly, is you can condense and expand logarithms. It's similar to the rules of exponents. So with exponents, you should have known that if I have x to the power 2 times x to the power 3, what can I make that? X to the power of, oh, bless it. Okay, you add, because think about it, this is 2 x's multiplied together, right? And then another 3 x's multiplied with it. How many x's is that total? 5, so it's x to the 5th. So you add your exponents with multiplying. Okay? And then when we was dividing, when we said x to the 7th divided by x squared, it's the same thing as saying, well, I have 7 x's, and I divide out 2. So these 2 go away with these 2, and I'm left with 5 because I subtracted. Okay, these are exponent rules that you should have learned back in probably 8th grade, I would assume, maybe even before for some of you. So it's really not that bad of a concept if you can just know your exponent rules, because in the short version of a logarithm, if we have log of xy, so they're multiplied, the long version, the expanded version, is added of log of x plus log of y. So similar concepts, which should make sense because you should know that logarithms are very similar to exponents already. Okay. Make sure if you're expanding it, I need to see multiple logs wrote down. I shouldn't just see one log at the end. I should see log of x plus log of y. Do not put log of x plus y without that second log. That's the biggest mistake I see. I would not be shocked if they tried something like that to confuse you. Log of x over y. Same thing where division was subtraction in exponent world, it's the same thing here. Except for I'm going to take log of x, now I'm going to subtract log of y. Notice that I took the top and I subtracted the bottom. You should be able to go both ways on these. You should be able to go from condensed to expanded and expanded from condensed. Any questions about those two? Okay, those are your two big ones. Your next one is really big on solving equations and stuff like that. It's very important. You have log of x to the power of y. It's the same thing as saying y times log of x. Okay. So you can always move that forward, or if you need it shorter, you can pull it back as an actual exponent. That would be helpful if I was just trying to solve a quick one, I'm not talking about a hard problem, but like if I was doing 2 log of that's probably not going. Oh, it's not even a grade off. 25. Okay, if I made it, oh no, I wanted that 5. I took it. 2 log of 5. So if I said 2 log of 5, I'll rewrite it to where it's not messed up. I could switch it to log 5 squared. Which is log of 25. And I could either leave it that way. If it's something that you can solve, solve it. Now, that one's going to be like 10 to some power is 25. I don't know that number. You may, but I don't. So you would need to actually type it in or something like that. It's going to be a decimal. But it would get it more condensed. Which is like 1.397. I don't think that's important, but you now know anyways. Okay, any questions about the 3 main rules? Okay, I'm going to go through a couple of examples of them so you can see them a little better. So if I told you to expand, and I gave you log of uv cubed, you have to look at it and say, what is happening between the variables? And we talked about, when we did this originally, that the number of variables is the number of amount of logs I should see. So I see 2 variables, so I know I'm going to separate it into 2 individual logs. Okay, what is u and v doing? Okay, I hear mumbles.
Being cubed.
Okay, v is being cubed, and we'll have to deal with that, but u and v together is being multiplied. Okay, if it's being multiplied, how do we expand it? Add. So you're going to say log of u plus log of v cubed. Notice that cube did not go to the u, it only went to the v. So I have to only attach it to it. This is not completely expanded. In completely expanded format, I do not have any exponents. What can I do with that 3? Which log?
Log of u.
Yeah, put it in front of the log of v. Very good. So log of u plus 3 log of v. And that would be your answer. That would be a completely expanded format. Is there any questions about that? I'll give one that's a little bit harder next, and then if you have questions, let me know. Okay, so number 2, if you see ln, that's just natural log. Instead of operating in a base of 10, it operates in a base of e, which is a number we talked about. It's like 2.7 something. It's not a big deal. It operates the same exact way. You're just writing ln instead of log in that point. But we'll talk more about it in solving. So it's xz over y to the 6, all to the power 6. Now you have a couple different options of how to tackle this first, and every person sees things differently, so every person is going to tackle it different. So just for time's sake, I'm going to show you how I would look at it, but I'm not saying you have to go with my way. I don't care. You know me. You do what you need to do, okay, other than cheating. So I have Ln. I would say I'm just going to distribute the 6 to everything. So it's not just x, it's x to the power 6. It's not just z, it's z to the power 6. And then y to the power 6 to the power of another 6. Can you remember what our rule is if we have a power to a power with exponents? You what?
Multiply.
Very good. You multiply. So y to the power of 36. Okay, make sure you know that. Okay, that takes care of some confusion with the parentheses, and I know what everything belongs to. I'm going to look at this now and go, okay, I need to separate it, but I see a couple things happening. I see multiplication happening, and I see division. I always tackle the division first. That's what I do. If there's multiplication at the top, then that has to be separated last. So I'm going to say Ln of x to the 6, z to the 6, minus Ln of y to the power 36. I want you to realize I've not taken anything and just threw the final answer down there. I've taken it step by step. And if you struggle with these, that's what you need to do, is take it step by step. Once I have the division taken care of, I now separate my x and my z because they're multiplying. So Ln of x to the 6 plus Ln of z to the 6 minus Ln of y to the power 36. Any questions about that? Kind of remember what I told you earlier, however many variable is, that's how many logs, or in this case, natural logs, I should see. I had 3 variables, I see 3 sets of Ln. If you go back and double check at the end and you don't have that rule work out, you've done something wrong. I have exponents, which if I'm expanding, I cannot have, so I have to get rid of those. So it's 6 Ln of x plus 6 Ln of z minus 36 Ln of y. Any questions? From what I could tell, most people really like to expand. It's condensing that people struggle with more than that one. Condensing is really important though, because that's what we use to solve. So I'm going to go through a couple of condensing, but then I'm going to show you how we use them to solve equations, which is the main thing. And if they're going to test you on something, they're going to test you probably in an equation. That way it's testing multiple concepts, like the actual equation itself plus can you condense. But I can't, they may give you one where you actually fully condense or fully expand. So condensing, we're going to do, I don't like that example. I like, we're not going to do that. Yeah, I like this one. Okay, so we have 12 log base 7 of x minus 2 log base 7 of v. Okay? You're working backwards. You're going from this, and then you're going to that. Okay? you cannot condense them, you cannot combine them in any way if the actual logs are not the same. So if this was a log base 7 and this was a log base 5, I would just leave it alone. I couldn't do anything. But because I can combine them because they're both logs, I'm first of all going to move my exponents. So log base 7 of x to the power of 12 minus log base 7 of v to the power of 2. Then what do I do?
Division.
Yep, I make the subtraction division. When I condense, I should only have one log in the end. I should not see multiple logs. It's the whole point of condensing. So log base 7 of x to the power of 12 divided by v squared. Any questions about that? Yes.
Like if we want to do an extra step and just like do log 7 x to the 12 over log 7 b to the second, like just do it like that and then separate it after that. Can we do that?
Meaning go like this, log of 7 x to the 12 divided by log 7 b squared.
Yeah.
You cannot do that because that's two separate things at that point.
Yeah, but like being separated, like if you just want to do an extra step, like if it helps you see it more, and then take the log.
If it helps you see it more mathematically, it's not a correct step. Okay. If it helps you see it more and you can get to here with only one log, I'm fine with it. But just understand that mathematically it is incorrect. So, like, you know, if you go to Miss Morse's class next and she sees it and freaks out, don't be surprised. Okay. I think I understand what mathematically you're seeing, but it would negate what a logarithm does mathematically. That's why it doesn't work. And I know that doesn't make sense to you. It would take too long to explain though and I think it would just confuse you. So if you need it, that's fine, but make sure you get it to where it's one log. Okay? And if you start messing up with that, don't do that. Okay? And so we're gonna scratch it out. So my fear is that, you know, the video won't have sound and then they'll see that and then flip out and I can't have that. Okay. Is that good? Is there any more questions on that part? Sorry, I'm just like rip it off. Okay. Let's see. Let's do one that actually solves with that so you can see where it's helpful. So I'm gonna solve, which solving is the biggest part of this. Obviously, you know, you want to know that you're actually doing something with them when you're solving. You feel like you're actually, you know, accomplishing something instead of just like rewriting in Crazy World. So it does have a purpose, I promise, whether you see the purpose or not. I may do a couple of these. I don't know. It depends on how I feel. Log base 5 of x plus 4 minus log base 5 of x, and it equals 2. Okay, if I have two logs and then a separate number, so I have a log here, and then a number over here, I can't just move the one log over and cancel them out or anything. If I could, that would be great, but I can't. I will show you an example of those, and those are the easiest ones to do. So I have to get this to where it's one log, because at this moment, you can't understand how to solve that without making it one log. And they're both the same base, so it's convenient. So we have log base 5 What does subtraction make it? Division. So you have x plus 4 over x equals 2. Which at the moment, that may look crazy to you still, but I promise it will come together. So right now we have log base 5 of x plus 4 divided by x equals 2. Now we're going to go back to one of the things we did earlier. We're going to write it in exponential form, which is one of the main reasons why we had to learn how to write in exponential form in the first place. What is my base? 5, thank you. What is it to the power of? I hear things, but not very well. 2. Base, exponent. If you don't know that, you need to remember it. I don't know what other tricks to tell you other than base in the basement, exponent, exile. I also see people like do some crazy curly thing. I don't know if that helps you. It does not help me. It's whatever works for you, not me. Okay, so 5 squared equals x plus 4 over x. Okay, 5 squared is just 25. I think everybody here knows that. Okay, I need to get those x's separated because right now I have x plus 4 over x, and that's not good. How can I move that divided by x over?
By x.
Yeah, I can times it by x. So I can times both sides by x. And that gets it to looking something more like you've seen before. So 25x equals x plus 4. Okay. You're probably a lot more comfortable with that than you ever were with what we started out with. What do I do now? Subtract. I would move over x. If you want to move over 25x, that's fine. It's just going to create more work. It's, you know, whatever makes you happy. So I end up with 24x equals 4. And then we just divide by 24 on both sides. So x equals 1/6. So hopefully that kind of shows you how condensing will help. It's not just to, you know, me to make you rewrite it 50 times or to torture you. Like it really is used for something. And logarithms and exponentials are used highly in anything population-wise, tracking anything in growth, stuff like that. It's really helpful for. So let's see if I can find another example. And I'm sure give you kind of a minute to work through it if I can find one, which I know I have a billion. Yeah, we'll do this one. I'll give you just a minute and then I'll write out how I did it. So log of x minus log of 8 equals 1. And I want you to try using the same concept of condensing to get there. you should have looked at it and said, hey, there's a minus, so that's division. So log of x over 8, and that equals 1. Then after you switch it into condensed form, you say, okay, let's put it in exponential form. Well, I don't have a number there for the base, so it just seems to be a 10. So it's 10 to the power of 1 equals x over 8. And then I say, okay, well, I need to get rid of my 8, so I multiply both sides and I get x equals 80. Is there questions there? Always look at it and go, can I condense it in some way? And then after that, would exponential form help me in some way? And if you can just do that, sometimes that will kind of spur you on to the right direction. There's a lot of different kinds of equations. This is just one of them that has logs, and then I showed you one other type that had them. I want to show you another one that has a pretty good, it's a little bit easier actually. I think I can even fit it over here. So if we have log of x plus log of 9 equals log of 20. You're still going to have to use the same concept of combining something. So you're still going to have to say log of x plus log of 9 and condense it. And say that, hey, that's log of 9x equals log of 20. But after that, it's a little bit easier because you don't really have to do exponential form. If you have log with the same base equals log of the same base, and nothing else, like I don't have a -5 on the outside of it or anything like that, and those logs basically just negate each other, and we know that 9x and 20 are the same number because they equal when I put them in log. So 9x equals 20, and then you just divide. It's like 2.2, I think. Sometimes you may even have one that's even just like, hey, log of 5 equals log of x, so, well, 5 equals x, okay? It can be as simple as that, where you don't even have to condense. Is there any questions about that? Okay. Does anybody need more time with that? Let me double check that I've gotten every kind that you need. Okay. So that's logarithmic functions, but you also have to know how to solve exponential functions, and you're going to do that using logs. So we use kind of exponents to help us solve logs. Now we're going to use logs to help us solve these exponential problems. So what numbers? We're just going to put another 12. Okay. I'm going to have -7 times 7 to the power of -10x equals -77. Anytime you have a variable in your exponent, it's considered to be an exponential problem. Okay. So if you think back to your functions, graphing the function of x to the power 2, that's a quadratic. But if I graph 2 to the power of x, if I switch what I have, then I'm now in the exponential. So the variable in the exponent is an exponential function instead of whatever else it may be. So I need to actually get my base and my exponent stuff alone. So I need to kind of solve for this. How do I move over that -7? What's it doing for this, to this? What does the dot in between mean? It's multiplying. How do I undo multiplication? Yeah, so I'm going to divide both sides by -7. Seven to the power of -10x equals 11. Okay, you need to do the same kind of questions that I just did. If you look at it and you're confused, go, okay, well, this is the main part. You can tell it's like the main meat of the problem. I need to get it alone. How do I move this? And if you can't answer that, go, what is it doing to it? Okay, if there's a dot in multiplication, divide. Okay, you know these concepts. You can ask yourself a question. You just have to learn how to ask yourself a question. Okay, now we have 7 to the power of -10x equals 11. Now, could you technically start plugging in numbers and guess? Well, yes, you could. If it's multiple choice, could you plug in numbers and start guessing, like checking to see which one works? Yes. I'm not saying you can't do that, but the algebraic way to do it is not that bad. Okay? Logarithms allow us to pull things out of the exponent if we expand them. So I'm going to take the log of both sides. So I'm going to say, hey, I've got the log of 7 to the power of -10x equals the log of 11. Because what we do to one side, we still have to do to the other. So if I take the log of one, I have to take the log of the other. The whole reason why I'm doing that is because of that rule that says, hey, you have an exponent, it can go out front. So it takes something I have in the exponent, and now it actually puts it as a normal number, and I know how to operate in normal numbers. So -10x times log of 7 equals log of 11. Any questions about that? So anytime you're solving for a variable and an exponent, you need to think, hey, I need to use logarithms. Okay? I need to solve for that x. I'm going to move log of 7 over. What is log of 7 doing? So we divide. So I'm going to divide both sides by log of 7. Okay? It's very possible that the state of North Carolina will decide to go, hey, we're just going to keep it as that and not give you the actual number. Okay? They could also institute change of base right there that we kind of talked about and said, hey, that's log base 7 of 11. Okay? So be prepared for both of those, because change of base can come back into play right there. So I'm going to kind of give you 3 ways you could see this answer. I know that's kind of confusing, but I don't ever, you should be able to switch between them. So I could also just have decimals, and it still equals -10x, right? So these are 3 different formats as we can see this answer. If this was the one they chose to go in the format of, or if you even chose to go that, if it was short answer for some reason, what do you have to do with -10? Divide it. Most people see the negative and they want to add, but it's not subtracting from x, it's multiplying with it. So I have to divide it on both sides. Well, if I divide it with this one, it just becomes log of 11 divided by -10 log 7. It just goes down with the log 7. With the decimal form, pretty easily, you just divide it by -10, so it'd be x equals -0.123. You'd actually just divide the number. And if it was this format they decided to write it in, it would say x equals log base 7 of 11 divided by negative 10. And you can end there. Okay. Be prepared for anything. Some of these you may be able to do really well, like you may be able to get the decimal, but you struggle with getting it in this format. If you can get the decimal and you really have tried to get it into the other format and you just can't, I showed you how to type them into your calculator. Just go back, type each answer choice in your calculator and see which one matches up, if it's that big of an issue. But I'm hoping we don't have to do that. I'm hoping we know the actual math. Any questions? Okay. So that covers those. I'm going to give you one more of those. I'll give you like a little bit of time like I did the last one, to where you have, you can kind of see if you can do it on your own. So number 2, go ahead and try 8 to the power negative 8n minus 8 equals 78. If you need a calculator and you don't have one, you can get one. Okay, so if you've not noticed, it's posted. We have 8 to the power negative 8n minus 8 equals 78. First thing I did was I added 8 to both sides, and I got 86. Then I said, okay, I need my exponent out. So I took the log of both sides. Is there any questions up to this point where I took the log of both sides?
Why did you have 8?
Because it's minus 8 and it's not up in the exponent thing, it's not attached. I have to get the meat of that problem by itself. Like normally you would get the variable by itself, right? That's your goal. Well, the only way to get the variable by itself is to get this whole thing by itself first before I take the log. So I had to add 8 to both sides. Any other questions about why I got to this point?
I messed up.
Okay. So when I took the log of both sides, I then pulled the negative 8n in front. And from there, it was more just a lot of manipulating. I moved log of 8 over by dividing. And you need to divide by negative 8. So here, I gave you the 3 options. You could have had this where you just divided by negative 8 and put it on the bottom. I gave you the one where you put it in the base form, so log base 8 of 86, then you divide it by negative 8. Or you could have decimal, which is negative 0.2678. Okay. You what?
I got negative 0.2675.
That's what I got.
It made a rounding error or something. Either one of our part, so that's fine. That's not enough to matter. Okay. Kaylee, are you okay with it other than just that adding the 8? Okay. And that's a small thing to fix, so. You okay?
I think I messed up and divided everything.
Okay, you understand why you messed up though?
Yes.
Okay. It's okay if you mess up, it's, can you fix it, you know, that's the problem. Does anybody have any questions about this? I may be wrong, I can't remember exactly, I think they have one similar to this on released items, but I can't remember if it's 2013 or what it is. So, I will go over, because they have done it before, I know it is your release item, this one kind of is. Oh, I'm sorry. You need it still?
Yeah, I'm just trying to look at the bottom of it.
Okay, sorry, you just have to film.
Why is there like a second 8 in the log? At the very, very bottom.
This one?
Yeah.
Okay, so here we had it divided by 8. This is just another way to write it. Remember when we had that change of form where we said, if I needed to solve for, I'm just going to write kind of something separate, okay? Log of 525. We would have said log of 25 divided by log of 5. You remember when I told you that at the beginning? It's the same thing in reverse. So I took this concept and I made it into this. So I took my log of 86 divided by log of 8 and I made it log base 8 of 86. Okay? So I'm trying to prepare you multiple ways to see it, because the one thing I despise about standardized testing is, yeah, you know the math, and that's not the problem. You just don't recognize how they're deciding to portray it. And so I have to show you every way that they could possibly portray it, which only takes, you know, a year or two. But that's one way that's very possible for them to show. Okay, any other questions? Okay, I'm going to show you one more kind of these exponential solving problems. You can't solve this one with logarithms. You have to manipulate it. I'm going to be honest, these annoy me. Not because they're hard per se, as much as they're just kind of stupid. But, you know, whatever. 243 to the power negative 3b equals 9 to the power negative 2b plus 2. I cannot use logarithms because I have 2 different bases and I have 2 sets of exponents. that have variables. So if I just had one that had a variable and exponent, it'd be different. Or if I just had one base, or they'd both be the same bases, it would be easy, no problem. But I have to kind of play with it to where it gets to what I need it to be, which I meant to check on that one. 4, 3 to the power of 5 in a second. Okay, there we go. 243 and 9, either it wants to switch 243 to where it's a base of 9, or because 9 is so in such a base of 3, it may be switching it to a base of 3. So that was my first thoughts when I saw this problem. Either I need to switch 243 with a base of 9, or I need to switch both of them to where they're in a base of 3. I will tell you just for time's sake, they're both supposed to be in a base of 3. I know that 3 to the power of 5 equals 243, and I know that 3 to the power of 2 equals 9. Okay? And all that it took really, I know the 3 squared is 9, it took me sitting there playing with it for a second. I went, hey, 9 cubed is like 700 and something, so obviously it's not the base of 9. But 3 to the power of 5, oh, that's 243. And so I knew we had to operate in the base of 3. If this whole thing confuses you, don't stress about this so much. I'm not worried about this concept that much because you could technically just plug in things. And I don't feel like you're missing out on great education at that point. So we have 243 to the power of negative 3b, but we're going to rewrite it, okay? I'm going to rewrite it in a base of 3. So if I know 243 is 3 to the power of 5, it's actually going to be 3 to the power of 5 times that negative 3. Okay? So I took it and I just kind of transformed it to where it's in a base of 3. It's the same as that number, I just added more to my exponent to kind of make up for it. So it's basically 3 to the power of negative 15b at that point. Is there questions about that? So I do this in parts. I kind of transform the first one, then I would go transform the second one, then I would set them equal to each other. So when I'm transforming the second one, 9 to the power of negative 2b plus 2, I want to say, okay, well, we know that's 3 squared, so it's 3 squared, and that squared will times the negative 2b plus 2. So I have 3 to the power of negative 4b plus 4 in my transformed state. Really not that hard. It's just sometimes you don't think to do it, or sometimes you struggle with finding what to actually raise it to. So if you struggle with it immensely, I don't want you to put like all the logarithms in this one thing and like freak out about it. Okay? It's not worth it. And freak out about something, freak out about condensing and expanding. So I'm going to now set them equal. So 3 to the power negative 15b equals 3 to the power negative 4b plus 4. Here's the great thing. Sometimes they give you problems where the bases are the same. And if the bases are the same, it's kind of the same situation if I had a log equals a log. I'm now on even playing field, and I don't have to worry about that 3 because I know whatever negative 15b is, it's the same as that thing as what negative 4b plus 4 is. Okay, so I don't have to worry about those 3's at that point because I have them the same on both sides. That's why you aim to do that. I will tell you, for those of you who are aiming to go to pre-cal and advanced ASM, this will be something that's expected of you, okay? And without a calculator. So, know that. I would then just do normal solving. I would add 4 to both sides, so I'd have negative 11b equals 4, and then I'd say b equals negative 4/11. Or you could get whatever decimal it is. I don't know what the decimal is off the top of my head. Okay? Any questions about that? Y'all good over there? Okay. Is there anything that we've talked about today that you need me to go back over, or you're confused about? That I can hit? Okay, throughout the week we may hit more on it, obviously, because some people have seen it, so I'll try to hit on some. I'm not gonna go over the graphs because I just don't have the kind of time to devote to it. But if you have questions in class, you can always ask about them too, okay? And thank y'all for coming. I've got all your names, so you're good to go. Will, do you want the rest of the notes you missed?
Yeah, sure. Well, I can tell you, I'm just coming like tomorrow after chemistry, because I have chemistry tomorrow.
Okay, that's fine.
Because like, I can't really like look at those without like.
Well, tomorrow's a different topic, but I'll take it. That's why the computer's up there. So if you want to, I'll post it and you can look at it and catch whatever little part you missed.
Alright, I get logs though, so like I don't understand.
Okay.